Okay, 6.3 part one. This is vectors. So go through the basics of vectors. So how do you represent and perform operations with vector quantities? Well, first, that's a couple things you should know about vectors. A vector is a directed line segment. A directed line segment, not a line segment. Remember, line segment has an endpoint, and it's directed because it has just that, has direction. Has direction. And it has magnitude. And what does that mean? In other words, it has length. So if we come over here, we look at this is a vector PQ, and this initial point is our start, and the terminal point is our ending. Is where it ends. Okay, and you can see how typically a vector is drawn with this sort of half arrow on top of it, and the arrow here, this arrow right here, the arrow shows the direction. Arrow shows, God, I need to make this bigger. Sorry. Shows direction. Let's see, they are written as, well, we just talked about that. There's different ways of the different notation. Okay, notation. In other words, a way. So sometimes vectors are written just as like U, okay? Or sometimes they're written as like, V with the arrow over it, and then sometimes they're written, like P, Q. So all of these are equivalent ways of writing a vector. All right, just sort of depends on the situation. Okay. When the initial point of the vector, oops, that's not what I meant to do. When the initial point of the vector is at the origin, we say the vector is in the standard position. So if it's at the origin of a coordinate plane, that's standard position. When in standard position, the vector can be expressed by its terminal point as written v equals v sub 1, v sub 2. So what does that mean? Gets a little crazy. So here's our vector PQ. So PQ is going to be, there's these points out here. Oops. Let's do it like this. Let's go out here and write. Okay. Let's say like this is, so this is going to have and this is going to be x sub 1 and y sub 1. And this is going to be x sub 2, y sub 2, right? And this is P and this is Q. So if we were writing the vector, it would be we'll say the ending point minus the starting point, if that makes sense. That should kind of make sense, should be familiar to you. So it's the terminal point minus the initial point. On this this equation here, there is a little bit of a mistake. So it's x sub 2 minus x sub 1. So it would be x sub 2 minus x sub 1, and then that would give you your first value there. That would give you this v sub x, right? X sub 1, x sub minus x sub 2. Then you would take y sub 2 minus y sub 1, y sub 2 minus y sub 1, and that would give you this value here. Now there should not be a cross that out. It's not supposed to be a minus sign there. It should be a comma, okay? So those are the components. That's the component form of our vector, and then we could then simplify that by just writing it as unit vector. Oops. V sub 1 and V sub 2 are known as the components of V. I just mentioned that. When both initial and terminal points lie on the origin. This is known as a zero vector, is denoted as basically zero vector. So kind of silly, but this is like, okay, if both the x and y, if both the terminal and initial are on the origin, then we have a zero vector, which I think comes up at some point in time. Let's take a look at a couple of things. Magnitude. So magnitude we talked about as being the the distance, okay, or the length. So magnitude is length. And it's the notation for magnitude is this. It kind of looks like a double absolute value sign. So it's this. It's like our V with the little arrow on top of it, and then these sort of double absolute values. And the actual equation for it is the square root of, I guess we say V sub x, the x component squared, plus V sub the y component squared. So the vector of the x and the vector of the y. You'll see that a little bit more in a minute. And then the unit vector has a magnitude of 1. So we will talk about unit vectors. It has a magnitude of 1. Okay, we'll see. So example, show that vectors that have the same magnitude. Show that vectors have the same magnitude. Okay, so we're going to let U represent by a directed line segment P to Q, 0, 0 to 3, 2, and we're going to let V represent another one. So we're going to write each vector in component form to show that U equals V. All right, so PQ would be 3 minus 0, 3 minus 0, comma, 2 minus 0, 2 minus 0, right? So that would equal 3 minus 0 is 3, comma, 2 minus 0 is 2, okay? So there's our vector U, and you can see it in component form. In component form, it is 3, 2. So now we'll look at the other one, which is RS. Okay, and here we take 4 minus 1, right? So 4 minus 1 are our x values from our terminal to our initial, and then our y value terminal to initial, so 4 minus 2. Okay. 4 minus 1 is 3. 4 minus 2 is 2. Oops. And that is vector V. And so we can see that, therefore, vector U equals vector V. Okay, we're going to get into multiple examples here, but I've got to run for a minute and handle